Multiplying algebraic fractions. These are no different to when we multiply numerical ones. So for example, 4 over x times 3 over y. Just multiply numerators, so 4 times 3 is 12. Multiply denominators, x times y, we'll write as xy. Now there's no simplification needed in this case because there are no common factors between the numerators and the denominators. Over the next example, we'll see where we need a bit to do some cancelling. You can multiply it all together like we just done and then cancel afterwards, or sometimes actually easier to cancel first and then do your multiplication afterwards. So we've got 8x power 4 over 3y to power 4 times 9y over 10x squared. So there's quite a number of things in common in those. We've got 8 and 10 are both multiples of 2, 3 and 9 multiples of 3. We've got powers of y and we've got powers of x. Let's rewrite that and let's see what it will cancel down to. Okay, we start with, let's divide 8 and 10 by 2. So 10 now becomes 5, the 8 becomes 4. Next, we divide by x squared, so the x squared disappears on the bottom, x to the power of 4 becomes x to the power of 2. Next we'll divide by 3, so 3 divided by 3 is 1, 9 divided by 3 is 3, and finally y. And y divided by y, so we get y, that's 1, and then y power 4 is y cubed. So if you look at what's left, on the top we've got 4 times 3 is 12, x squared. On the bottom we've got 5y cubed. Okay. In these examples here where we have algebraic expressions in the top and the bottom, we sometimes find that actually if we factorise, it suddenly becomes a lot easier. So the only thing we can factorise is x cubed plus 5x squared. They both have a common factor of x squared. So we'll have x squared times x plus 5 on the bottom. You can now see that we have some common factors. First of all, the numbers, 6 and 10. Both those are even, so you divide those by 2. We'll have 5, 10 divided by 2 is 5, and 6 divided by 2 is 3. Then of course we've got an x plus 5 and x plus 5 both cancel, so all that's left now on the top is 5 times 1, because x plus 5 disappears, we've still got, there's 1 on top of that, and then 3x squared. Okay, we may end up with somewhere we have quadratics. That doesn't look very nice. There's a lot straight away. Like, how can you simplify that? Well, the key is factorise. Top and bottom of both of them, and see if there are any common factors between the top and the bottom. Okay, so we end up with x plus 3 times x plus 1 on the top, over x plus 7 over x minus 2. Second fraction is x plus 3 x minus 2, and x plus 1 x minus 8. We can see there in the first one we have an x plus 1 on the top, second we have x plus 1 on the bottom, so they will cancel, and then we have x minus 2 in the bottom of the first one, x minus 2 on the top. So both of those can, and then all we're left with is x plus 3 times x 3 on the top, x plus 7 times x minus 8 on the bottom. We do not need to expand those brackets out. It's perfectly acceptable to leave them as they are. So we'll have x plus 3 all squared on the top, x plus 7 times x minus 8. There we go.